Tonight on the first installment of the 1996 Astronomy Show, we take a look at the year in preview. We get an insight into making telescopes, and of course, David Dodge with Astro News. All this and more on the Astronomy Show.
Welcome to 1996 and the January edition of the Astronomy Show. It's that time we all turn in our old calendars, put up new ones. Astronomy is unique in the sense that we can actually make some pretty good predictions what's going to be coming up in the next year. Certainly far better than anything you're going to see in your average supermarket tabloid. So tonight we're doing shuttle missions, we're doing planets, we're doing meteors, and we're doing a few other things I think you'll find interesting too. So stick around, see what's happening in 1996.
In 1995, the highlights of the year for Canada in space was the launch of RadarSAT at the beginning of November, and a few days later, the launch of Chris Hadfield aboard the Shuttle Atlantis. Chris Hadfield, of course, assisted in the successful docking with the Mir space station and became the first Canadian to actually visit Mir. This year, we have the beginning of full operations for RadarSAT and 2 flights by Canadian astronauts. The first one will be in May with Mark Garneau, who Canadians remember as the first Canadian astronaut. If all goes according to plan, Mark Garneau will be the first Canadian to fly twice into space. He will be flying aboard a mission that features the Spartan free-flying satellite, which will obtain data on space science when it is released by the Canadarm and then later picked up by the Shuttle. This mission is supposed to last in the neighborhood of 9 or 10 days and will be aboard the Shuttle Endeavour. Garneau's first flight was in 1984 aboard the Shuttle Challenger, and as you can see him here, his backup was a fellow named Bob Thirsk. Bob Thirsk is going to finally make his first flight into space after 12 years in the astronaut corps, about 5 weeks after Garneau. He will be aboard Columbia for a space lab flight. Thirsk, who's an engineer and a physician, will be involved in a number of medical experiments on the space lab flight. Thirsk, by the way, is the first astronaut to have come from British Columbia. He was born in New Westminster in 1953, and right now, amongst other things, he's an adjunct professor at the University of Victoria. The flights of Bob Thirsk and Mark Garneau will be part of another busy year for the shuttle, which will feature more rendezvous with the Mir space station and the usual array of scientific missions.
Predictions for 1996. Now, in astronomy, a lot of things can be predicted. You just have to look up a publication like the Observer's Handbook or Guy Ottewell's Astronomical Calendar. You can find out when meteor showers are, when planets do their particular dances. But there's a lot of unpredictable things in astronomy as well, and sometimes there's even an element of predictability to them. And we can guess, for example, there'll be somewhere between 2 and 3 dozen comets discovered next year. They, instead of numbering these things, gave them letters of the alphabet. In the last several years, when reporting has been quite good, we've run out of letters toward the end of the year and had to resort to subscripts. There's a new method of naming comets, though, that's just gone into effect, so it's another prediction I can make. Sometime during 1996, one astronomer will turn to another discussing a comet and say, what are we supposed to call this thing anyway? What else will be discovered? Supernovas, another thing you can't predict with any exactness, but there'll be a roughly similar number of those discovered as well. Most of them will be in galaxies so far away and so faint that they won't even have catalog numbers. There's a distant chance that we will see a supernova in our own galaxy. We're horribly overdue for that. Terrible irony is we haven't seen one of these since 5 years before the invention of the telescope. So if you're a betting person and you like the long odds, there's about a 1 in 100 chance or so that there will be a naked eye supernova next year. It'll be well worth seeing. What other things can we predict? Now, there'll be probably at least half a dozen images that will come out of the Hubble Space Telescope that will make everybody go ooh and ah when they see them, and we'll all tie up the internet for hours on end because everybody and his poodle will want to download a copy of these things. There will be roughly about half that number of images of equal magnificence and equal significance that will come out of the Keck telescope that hardly anybody will see because they don't have nearly as good a public relations department as NASA does. What other things will come along next year? Well, there'll be probably about another half dozen or so false alarms in the search for extraterrestrial intelligence, most of which will be due to man-made interference, and some of which they'll never be able to track down, so they'll still be mystifying. And there'll be several thousand UFO reports. Many of them will be entirely sincere, quite a few of them will be completely bogus, and probably not one of them will be definitive. Those are my predictions for next year. Does that help?
In 1995, the Space Shuttle visited the Russian Mir space station twice. These are the first of two, but of about 9 to 10 flights. They're designed basically to teach the Americans, the Russians, Canadians, Europeans, and Japanese how to work together when they actually start building the International Space Station starting at the end of 1997. This year, there will be 3 shuttle missions to the Mir space station. Mission STS-76, which will be launching in March, STS-79, which will be launching in August, STS-81 in December. Basically, what will happen is the shuttle will dock with Mir, the shuttle will transfer cargo to Mir, experiments and film and other results will be transferred from Mir back to the shuttle. Shuttle will bring them back. 2 Americans will be left on board Mir at various times during the year, so that the Americans start to get some of that long-term space experience that they haven't had since they did Skylab. Some of you may have been following the missions on Rogers Cable. We were lucky enough this year to get both missions through the NASA Select channel. If you would like to see these missions on your home TV, write your local Rogers Cable station and say you'd like to see NASA Select carried for these missions.
There's nothing more spectacular than having a brilliant Venus in the west just after sunset. That's what we're looking forward to seeing in 1996. Venus orbits the sun between the Earth and the sun and is often seen in the morning sky as well as the evening. But because of the various geometries of the Earth's position in space and Venus's position in space, we don't get to see it as clearly as we will in 1996. Venus is brilliant because it's covered in clouds. Those clouds are not very nice clouds. They're made of sulfuric acid, and the atmosphere of Venus is carbon dioxide, and the air temperature underneath the clouds is something like 800 degrees hot. It's not a very nice place to visit, but it's a beautiful planet to look at. It'll go through phases throughout the year as the moon goes through phases because Venus goes around the sun as the moon goes around the Earth. Now, we've been seeing Venus in the evening sky from about the latter part of November. And in December, around December 24th, I think, we saw Venus and the moon in the western sky. Well, that's going to repeat itself a couple of times throughout the 1996. Around the 20th of each month, January 20th, February 21st, and so on, Moon and Venus will be in the western sky. It'll be very interesting to look at. Notice how Venus will get higher in the sky as each day goes by because of our ever-changing position in space. On the 21st of February, Venus and Saturn will be extremely close together. That'll be something worth looking at. It'll be about 1 degree apart. So that's my choice of things to look at in the nighttime sky for 1996. The reason I've chosen Venus is because Venus was in the sky much like it will be in May of this year when I bought my telescope 20-odd years ago, and Venus was the first planet I looked at. So I look forward to seeing Venus, and it's high in the western sky because it reminds me of the first time I had my telescope.
Let us now look ahead to the major meteor showers of 1996. This part of the astronomy show is dedicated to all those chicken littles out there who see a few meteors streaking about the heavens and then conclude that the sky is falling. Actually, the Earth in its orbit around the Sun sweeps up something like 400 tons of debris from space every day. Most of that debris is very, very tiny, dust-sized grains. Some of the larger things are about the size, say, of a pea or something like that. And they make for the very bright meteors we tend to see in the night sky. Those meteors can be seen any night of the year. They're called sporadic meteors. You go out on a nice dark night when the moon isn't up, look around the night sky, and you'll see roughly 2 to 5 fairly good streaks of meteors every night. But every now and then, the Earth in its orbit runs across a stream of debris left by a comet or by chippings and pulverizings from an asteroid, and this produces what is called a meteor shower. For 1996, the best meteor showers are those that take place on dark nights when the moon is not blotting out the night sky, so that you can see most meteors when the sky is darkest. And the first meteor shower of '96 that's going to be pretty good is called the Lyrids. Starting on about 6 days, focused around the night of the 21st of April. Each meteor shower has a peak, and the peak for the Lyrid should be sometime after midnight as we go from the 21st to the 22nd of April. A meteor shower is called the Lyrids, for example, because it seems to emanate from a constellation. And the constellation in this case is the constellation of Lyra, which you will find in the northeastern sky in the springtime. Later in the year, in August, we come to the famous Perseids meteor shower. It runs about 4 days, peaking around the night of August 12th. Again, the moon won't be a problem. It should be a very fine display. Then later in the year, in the middle of November, in the middle of December, we have the Leonids and the Geminids. From Vancouver, we probably won't see them anyway because it'll be rained out. But if there are some good nights to view these things, look particularly for the Leonids this coming November and also for the next couple of years. Sooner or later, it's predicted that the Leonids will put on quite a display with a shower of meteors going well over 100 to 1,000 meteors per hour. So these are things that we can look forward to in 1996 to observe meteors, go out on the night of the shower when it's supposed to peak, go out there in a dark sky, get away from the city lights, take along a few friends so that you can look up towards the top of the sky and in the direction from the zenith of the sky to the radiant where the constellation is that the meteors seem to come out of, and that way you'll get your best results. All you need is a good pair of eyes and possibly a little portable lounge chair so you can observe meteors in comfort.
Well, it's my pleasure to discuss and talk about the RadarSAT in 1996. And our club is one of the more active clubs across Canada. There are more than 20 organizations of the RadarSAT with more than 4,000 members, and we have over 200. We meet every second Tuesday of the month at the H.R. McMillan Planetarium, where we have a number of excellent speakers. Just as an example, of last year in 1995, we had such speakers as Clark Chapman from the Galileo probe. We also had Sidney Vandenberg and Peter Stetson from the DAO, and Eugene Shoemaker, of course, of Comet Shoemaker-Levy fame. And I know that our speaker coordinator, Barry Sanko, will undoubtedly have a number of excellent speakers for 1996. We also do a number of community events, including our Sidewalk Star Party down at English Bay, which runs in April and September. And I'm really looking forward to the one in September this year, as we have a special star. Actually, it isn't a star, it's going to be the moon. And we're going to be having a total lunar eclipse on September 26th. We'll have numerous telescopes set up, and the public is more than welcome to come down for this particular event. Also, we have Astronomy Day, which is being held this year on April 20th. And this is a fun family event for everybody to enjoy, looking through the scopes, lots of things for the kids to do, etc. We also have our Fraser River Day in June, and we also have our star parties. As an example, we have two up at Manning Park, one in July, one in September. There's a large star party up in the Okanagan in August, right around the Perseid Meteor Showers, and there will be other events that we'll be doing during the year too. So I'd like to welcome anybody to come down to the meetings on the second Tuesday. We have Astro coffee and cosmic cookies for you to enjoy. And I also want to mention one other thing that we're going to be involved with this year, and that is a search for comets and supernovas. There are only apparently 11 organizations throughout the world that are involved in this, and we, along with our comrades from the Halifax Club, are going to be doing this of a brand new facility out in Maple Ridge. We're building a dome out there, and we're very excited that we're going to be doing some scientific research work in astronomy. So on behalf of the RadarSAT, we wish you a Happy New Year.
Welcome back to the Astronomy Show and the January version of Astro News. Well, astronomically, there's not much happening in the skies this month, but as usual, we'll start off with the phases of the moon. Full moon is on the 5th, last quarter is on the 13th, new moon is on the 20th, and first quarter is on the 27th. This month's full moon is called, naturally enough, the moon after Yule. Now, this month's new moon marks the commencement of Ramadan. Ramadan is the highest of holy months of the Islam faith. For one whole month, from new moon to new moon, followers of Islam must fast. They must not eat between sunrise and sunset. So they have to know when the new moon is. So the new moon this month, of course, is on the 20th, and Ramadan ends in February's new moon, February the 18th. Does it feel a little bit warmer right now? It should, because on January 3rd, the Earth was at its closest point, or perihelion, to the Sun. It was closest at 11 p.m., just before midnight on the 3rd. We were only 147 million kilometers away from the Sun. Did you feel that extra heat? I don't think so. That bright star in the west is Venus. Venus is the nearest planet to the Earth right now, and it's easy to spot after sunset. Venus is bright because it's close to the Earth, and it's entirely shrouded in clouds. So the sunlight it receives is bounced back off into space, and the old inverse square law works to our advantage. If you got a telescope for Christmas, this would be a perfect target to choose to look at through your telescope. Notice that Venus is not round. Venus is gibbous shaped. It's humped. Gibbous is the Latin word meaning humped. That's because of its position in space between the Earth, the angles between the Earth, the Sun, and Venus. Saturn is easy to spot. It's still in the southwestern part of the sky. It's about 5 fist distances, or 50 degrees, above the southwestern horizon. And if you got a telescope for Christmas, this should definitely be on your hit list. But don't expect the rings to look like the pictures show, because for the past little while, and for the next month or so, the equator of the Sun, the equator of Saturn, and the equator of the Earth are all roughly in line, meaning for us here on the Earth, when we look at the Saturn, the rings will be all but invisible and very, very difficult to spot. Well, as I said at the outset, there's not much to see in the sky this month, so that's it for Astro News, and have a Happy New Year.
In October and November, the Astronomy Show carried features on RadarSAT, an ambitious Canadian satellite program. RadarSAT 1 was launched from Vandenberg Air Force Base on November 4th, and since then, the $500 million satellite has been undergoing a period of checkout. On November 28th, RadarSAT sent down its first image. It was beamed to Earth at Gatineau, Quebec, and it shows, fittingly enough, a part of Canada, a very historic part of Canada, Cape Breton Island. In this photograph, you can see Sydney, Nova Scotia, and nearby Sydney, the historic fortress at Louisbourg. As well, you can see Brador Lake, and you can, if you look closely, you can even see a ship in the water. Now, this photograph was taken with sort of the medium resolution imager on RadarSAT. You can see down to a resolution of about 25 meters. But RadarSAT offers a wider scan image and also a narrower scan image that takes sharper images. The period of checkout and setup for RadarSAT is continuing, and RadarSAT is scheduled to begin full operations in February. RadarSAT International, the marketing arm for RadarSAT images, is in Richmond, BC, and they're already taking orders for images from RadarSAT, which can be used for oceanography, for prospecting, for looking for ships and oil slicks, and they are anticipating a good business.
Welcome back to the Astronomy Show. For the past year or so, we've been talking about things in the sky and how wonderful they are, but the one thing we haven't talked about is how to observe things in the sky. We talked about telescopes, but we'd like to bring in an expert, Gary Psionic, to talk about telescopes. Gary, you've made telescopes, and why don't we go through what a telescope is and how it works? And this is yours, I believe.
That's right, Dave, yes. Making telescopes is something that's not only a lot of fun to do, but it is also among the more rewarding ways to enjoy the night sky, because you are looking through an instrument that you've crafted with your own hands, and that gives you a fairly high degree of satisfaction and pleasure.
Did you make this whole thing yourself?
No, like most telescope makers, I make some parts and I buy others. There are some parts that just make no sense at all to make. And what you do when you make a telescope is you make as much as you feel like making, as little or as much as that is, and you buy the rest.
And what parts did you make on this one?
Well, the telescope tube assembly, which is the part this part here we usually describe as the tube assembly, is pretty much all I made, including the optical components, the main primary mirror, which is the part of the telescope that gathers up the light.
And that's at the bottom of the instrument.
That's
here.
right.
I don't think we can see it, but down at the bottom, oh, you're getting something, some reflection there.
Yeah.
All right.
Well, it's the shiny thing down at the bottom of the tube. And that's really where most of the work goes. The tube itself is made out of cardboard. It's actually concrete form tube. It's been covered with...
That's cheap.
Yes, it is. I think it's $12 for a 12-foot length. So you
That make a lot of telescopes.
You could make 4 telescopes like this using that material. And part of the advantage of making your own telescope is to save money, but that's not the main reason for doing it. The main reason is the satisfaction and the very real chance to build a telescope yourself that might be significantly better than one you can buy.
Really? You can actually make a telescope that is better than you can buy at telescope stores?
Yes, that's certainly the case. Really, it depends on how much time and effort you're willing to put into it. If you put a lot of effort into it, there's no reason on earth why you can't build a telescope far superior than most of the ones you can buy in your average camera store, certainly. And it really is a matter of how much effort. Now, this is perfectly reasonable for someone who's just starting out with their very first mirror to achieve. They can actually make one considerably better than they can buy.
Right, this has the mirror in it. The other kind of telescope is a refractor.
Which has a lens in the front which collects light. And those are generally not the kind of things that you want to mess with if you're home building. Both because the advantages of that design are largely put aside by the difficulty in making a lens surface. For example, when we talk about making the mirror, and that's really the heart of the telescope, we're talking about producing one optical surface. In the case of a refractor lens, you're talking about figuring 4 optical surfaces to a high degree of precision. And in the end, you gain very little, if anything, in the way of performance for your extra effort.
Great. Now, did you make, besides the mirror, what else did you make in the tube? Is there anything else that you made on this telescope?
Well, the various bits and pieces of the telescope which hold the mirrors in place, and that's really all a telescope is when you get right down to it. The mount here, the tripod, is a commercially made unit that was bought, although there's no reason on earth why you can't make that as well. I simply did not go through the tripod.
Are these expensive?
They can be. This is a fairly inexpensive one. This is about $150 for that mount.
If I'm not mistaken, $150? That's what I spent on my first telescope.
Yeah, I wouldn't be surprised if it was. A lot of these things, unfortunately, come from Japan, and with the yen and dollar difference, boy, some of the stuff you could get for fairly reasonable prices a few years back are no longer reasonable. So, you know, that's how it goes. Another reason to build it. And I actually bought this rather than building it just for the sake of expediency. I just wanted to get the telescope up and running quickly. So that was the route I chose.
Great. Well, let's just talk about the mount a little bit before we get into the mirror, because it's kind of an interesting looking mount. This is an equatorial mount, right?
That's correct,
Yeah.
as opposed to the other kind, which is the up-down, side-to-side mount, which is called the alt-azimuth.
Yeah, and then we'll find those in Dobsonian telescopes.
That's right. An equatorial mount has the advantage of needing adjustment in only one of its axis of rotation in order to track things across the sky, whereas with an alt-azimuth you're always moving a little up and a little over, a little up and a little over. And depending on the type of telescope mount and its design, that can be an advantage or a disadvantage. There's no clear-cut answer. For example, a sturdy alt-azimuth mount is always preferable to a shaky equatorial mount. And this would probably qualify as a shaky equatorial mount. People who perhaps had telescopes of their own at home may have well had a mount very similar to this. And it is none too solid.
What about the legs?
Legs, again, they come with the mount. The other main piece that was bought was the finder scope, and again, that's just one of those pieces that really makes no sense at all to build yourself. Although many people do. In fact, a good finder scope can be made out of some, plastic ABS tubing and some surplus lenses if you happen to be in possession of such things.
Pawn shops.
Pawn shops.
Right.
Old binoculars make great finder scopes.
Right.
The preceding program was produced through the facilities of Rogers Community 4, Vancouver. We want to hear from you and invite you to leave your comments and suggestions on our 24-hour response line message machine. Please call 731-5812.